In this lecture, we trace the curve x to the power 2 by 3 plus y to the power 2 by 3, which is equal to a to the power 2 by 3. We have to trace the curve x to the power 2 by 3 plus y to the power 2 by 3, which is equal to a to the power 2 by 3. Its parametric equation is given by x equal to a cos cube t and y equal to a sin cube t. So now, since its power is fractional, now it is 2 by 3 and 2 by 3. So now it is not possible to trace this Cartesian curve as a Cartesian curve. So we will try to convert this Cartesian curve by parametric curve by replacing x by a cos cube t and y equal to a sin cube t. Now we check the following points. The first point is limitations. Since the value of cosine t and sine t both lies between -1 to +1. Cosine t and sine t both lies between -1 to +1. So x lies between, because there is a in x and y. So x lies between -a to +a, and y also lies between -a to +a. The whole curve lies inside the circle of radius a. So the total curve will what? It will be inside the circle of radius a. Okay, this is the whole limit of the given curve. So now we have already defined that what is the limit of the given curve. The curve will never exceed to this circle of radius a. The second point is about symmetry. So first point is about x-axis. Since we know that cosine function is even function and sine function is odd function, right? So the given curve is symmetric about x-axis because cosine function is even function and sine function is odd function. Now the second about y-axis. Now if we replace t by pi minus t, then x with respect to pi minus t is a cos q pi minus t, and we know that cos pi minus t is nothing but minus cos t. So the x pi minus t is converted to minus xt, means it is odd function, and y with respect to pi minus t means if we replace here for t is pi minus t, so y of t minus pi minus t is a sine cube pi minus t, and sine pi minus t is nothing but sine pi, so it will become sine cube t, which is as usual yt. So y pi minus t is equal to yt, means it is even function with respect to t, and x is odd function with respect to pi minus t, and similarly x is odd function with respect to pi minus t. It shows that x is odd function and y is even function with respect to pi minus t. So the given curve is symmetric about y-axis. Let us go to the third point about opposite quadrant. Since x is odd function with respect to pi minus t and y is also odd function with respect to t, therefore the curve is symmetric about opposite quadrant. Now, what about the origin? Put t equal to 0 in 1, we get x equal to a and y equal to 0. Similarly, if we put t equal to pi by 2 in 1, we have x equal to 0 and y equal to a. So finally, the given curve does not pass through origin. Why? Because we are not getting for any value of t, we are not getting x equal to 0 as well as y equal to 0. For one value of t, if x and y both are 0, then we say that the curve passes through origin. But here, if we put x t equal to 0, we are getting x equal to a and y equal to 0. If we are putting t equal to pi by 2, then x equal to 0 and y equal to a. So the given curve does not pass through origin. Third point is asymptotes. Here no asymptotes, so no need to find out the asymptotes. The next important point is the tangent. So consider dy dx, which is equal to dy dt upon dx dt. And what is y? Y is nothing but a sine cube t. So if you want to find out dy dt, so dy dt is equal to derivative of sine cube t is 3a sine square t, and again derivative of sine t is cos t. So now here it is 3a sine square t cos t. Similarly, if you find out what is the derivative of y x equal to a cos cube t is nothing but dx dt, which is equal to 3a cos square t minus sine t upon okay, this is okay, and so this is what minus 3a cos square t into sine t. So now if we take the common thing, so here 3 will cancel, a will cancel, 1 sine t will cancel, 1 cos t is cancelled. So we have sine t upon minus cos t, which is minus 10t. Now let us make a table values. Let us make the following table values. When t equal to 0, when t equal to 0, the value of x is a, the value of y is 0, and dy dx is also 0 because tan 0 is nothing but 0. Now, if you put t equal to pi by 2, t equal to pi by 2, so what is the value of x? It is a cos cube t, value of y equal to a sine cube t. So if you put t equal to pi by 2, so cos pi by 2 is 0, sine pi by 2 is 1. So it is 0 and it is a, right? So 0, a. And if you put t is equal to pi by 2, so tan pi by 2 is nothing but infinity. So this is what it is, minus infinity. Minus infinity shows that it is the negative x, direct towards direction of negative axis. Okay, so let us try to trace the curve. The first thing we have to draw is we have to first draw the circle of radius a. So we have first drawn the circle of radius a, and since the curve is symmetric about both the axes as well as opposite quadrant, so we will only try to draw the part of the curve which lie in the first quadrant. So first quadrant, this is called t equal to 0. This is nothing but t equal to 0, t equal to pi by 2, t equal to pi, and t equal to 3 pi by 2. Now, this is the first part. So we want to trace only the first part of this curve. So this is nothing but a0 and this is nothing but 0a. 0a. Right? Now, since if we see the table values, t equal to 0, t equal to 0, this is t equal to 0. Let me draw it. This is t equal to 0. At t equal to 0, the value of x is a. The value of x is a, and the value of y is 0. Here y is 0. And dy dx is also 0. What it means? The tangent is parallel to x-axis. Means x-axis itself. This axis t equal to 0 is the tangent over here. So here, and since the curve is symmetric about, so we can draw this type of curve over here. This is tangent at that point a0. This is tangent. And since we have the symmetric about this axis, x-axis, so we are getting the same type of curve in the above of x-axis and below the x-axis. Similarly, if we come to the point y, in this point, uh, this is the tangent. This one is the tangent, negative y-axis. This is the tangent. And again, this is the one part of the curve and it is also symmetric about y-axis. So we get the same type of curve also. So if we join, if this and this, if we join, we are getting this type of curve in the first quadrant. And since it is symmetric about y-axis, so we are getting the same type of curve in the this side of the y-axis. And again, the curve is symmetric about x-axis, so we have to just fold this curve to in this manner. So we are getting this type of curve. So this is the approximate shape of the given curve. Thank you.